Hey, this is Mr. A. I hope that you are enjoying your e-learning day. And I miss you here in the classroom. It's just me talking to the camera. And so for the next few minutes, I'm going to talk to the camera and tell you what we would be doing in class if we were in person. So we have been talking about risk management and how that is important in keeping us safe when we fly airplanes because, well, it's inherently dangerous to fly an airplane, but it's something that's really fun to do. And so we want to continue to do it, but, as long as we can do it safely because nobody wants to hurt themselves or other people or damage property. So, one of the things that we have to do when we assess our risk is first recognize what potentially could happen and then analyze what the perceived risk is and then implement a plan to mitigate that risk, and that helps us make the decision whether to go or not to go. We are going to be doing something similar with the rocket launch. So we're going to have a safety management system, which is what I'm going to be talking to you about today in this short video. And the safety management system is what's going to help us determine if we're actually going to go and launch rockets on a particular day. So there's some certain criteria that we have to set forth. Those criteria are actually our procedures that we have put in place to mitigate the risk. Now, we have talked about, and your e-learning assignment today was to list the bad things that could happen during a rocket launch. And that's actually the first part of the safety management system is recognizing, analyzing, and writing what we're going to do to mitigate the risk. So you've already done like part one of the 4-part safety management system. Before I get too far ahead of myself, I want you to pause the video, get out a piece of paper and a pencil, and I'll tell you what to write on it. Okay, glad to have you back. I want you to write safety management system on your paper along with your name, because I may ask you to turn this in and I want you to be accountable for watching this video. So you giving me the piece of paper lets me know that you've watched it. And then what I want you to do is you can basically just copy what I write on the screen here, and that'll show me that you have listened to the entire video. Now, don't be that person that just fast forwards to the end of the video to see what I've written and then freeze that frame and then fill it in, because then you would miss my shenanigans, okay? So here we go. One of the risks that we have with launching rockets is fire, right? That's something that we talked about in the class. And so we know that potentially could happen. It's sort of an occasional or remote occurrence, but if it did happen, we could set the grass on fire and get in big trouble. So we don't really want to have that happen. So we are always going to keep a fire extinguisher with us. And there are some certain other things that reduce the risk. We use a blast plate on the launcher, which deflects the hot sparks from hitting the ground, and they hit the metal plate instead. So that's another thing that we can do. But just if you list that we have a fire extinguisher, that's going to help us to mitigate the risk of fire. One of the other hazards that we have is that the rocket is not going to go where we want it to go. We want it to go up, but there is a chance that if it flies incorrectly, it's going to go where we don't want it to go. And so let's just say the hazard is that someone will get hurt because it is flying, let's say, off course. This is going to be flying off course due to the fact that for some reason the design is inherently unstable, or maybe during the forces of launch it knocked off one of the stabilizing fins and it just started to go the wrong direction. So one of the things that we can do to mitigate that risk is to make sure that we do have a nice stable design. So we'll do a stability test. And that way we can just make sure that by design, the rocket should go straight up and not go horizontal and hit someone or hit a building. The next one I want to talk about is hitting an aircraft. So we don't want to collide. We don't want to hit any of the aircraft that are flying over. So we're going to practice what we call see and avoid. It's a pretty simple principle. If you see an airplane, don't launch your rocket. Fair enough? And then the last one is we could lose the rocket, or it could drift way over into the golf course over there at Greenville Country Club, or land in the middle of Cleveland Street. We don't want anybody to get hurt falling out of a tree or running out into the street to retrieve the rocket. So let's just say the rocket will get stuck in a tree. The rocket will get stuck in a tree when it comes down or drift off course. One of the things that when we plan to launch the rockets, we're going to do it in a nice open area. So if everything is working properly, the rocket goes up and then comes back down. But it wouldn't take too much of an imagination to think that if the wind is blowing a little bit, then that's going to take the rocket somewhere other than where we want it to come down. It could land in a tree, it could land in the power lines, it could land in Cleveland Street, like I said, or go over to the golf course, and who knows, we may never find it. So for number one, we are not going to do anything dangerous to retrieve the rocket. And the other thing we're going to do is we're not going to even launch it in the first place if the weather conditions, especially the winds, are not good. So I'm going to talk a little about that a little bit more in the other parts of the safety management system. So let's just take a moment, step back, look at what we've done, say, oh, okay, I understand this. This is everything that we talked about previously in class. What are these other three components of the four-component safety management system? You know, that might be a good ticket in the door. Entry ticket is for me to pass out index cards and have you write what are the four components of a safety management system. The second is employee involvement. So that means that if you're doing something in aviation and you're a commercial operator, that means that there's a business that's doing it and the business has employees. So you want to get everybody who's on the payroll involved and on board with this safety management system. I mean, if you're the boss, after all, you're paying for your employees, and you get to tell them what to do, and you get to make sure that they're safe whenever they're doing anything dangerous. Now, the same thing applies here to school. We're not a business or a company, but we are a learning institution, and we do have employees. That would be me. So in our safety management system, the employee involvement, I'm the only one who's getting paid, right? So Mr. A has the responsibility, he's ultimately responsible for anything bad that happens. That's really why we're going through this whole process, to make sure nothing bad happens. So employee involvement is Mr. Adamatis is going to act as the range safety officer. Okay? We will, in fact, when we do the rocket launch, there are several jobs, roles and responsibilities that each one of you will take. My job is going to be the range safety officer because I'm ultimately responsible for safety because I am the employee. Make sense? Okay. Number three, the third component of the safety management system, you know, sometimes we just say SMS. So if you hear me say SMS, I'm referring to the safety management system. So safety, training, and promotion. So guess what? You're getting trained in safety. So by virtue of the fact that you're watching this video, we are fulfilling the third part of our safety management system. So the AOPA curriculum, which is what we teach here at Greenville Tech Charter High School, we are teaching the RAID technique, so risk management, using the RAID technique for analyzing the possible risk. Remember, recognize, analyze, implement mitigation strategies to help us decide. And along with that, this SMS. So these are a couple of acronyms that we've been throwing around when we've been talking about aviation safety, the RAID method of analyzing and mitigating risk, and also the safety management system. So these are all part of the first couple of lessons in this unit, and so you are getting trained. Now, the last one is the culture of safety. And I just want to share with you that I have a strong regard for safety in aviation because in my family's history, there was a small airplane crash, and it happened because, well, my grandfather just wasn't making good aeronautical decision making. But you know what? He probably never had someone tell him about how to mitigate risk, how to manage and mitigate risk. So, you know, that was back 1958. So they weren't as good as, they didn't have as good a safety record back then as we do now, because we actually employ these techniques. So just by virtue of the fact that you are in my classroom, we are going to have a culture of safety, because I'm going to talk about it. I'm going to talk about it a lot. Heck, we have several lessons on it. One of the things that I'm not going to go into too much detail right now, but I want to talk. I just want to mention to you this PAVE, PAVE acronym. So I'm sorry, aviation's full of acronyms. PAVE. So in addition to us doing all these things to mitigate risk, we are not going to launch rockets unless we can safely say that we've satisfied all the conditions in this PAVE acronym. So PAVE stands for the pilot, the aircraft, the environment, I know the V's a little weird, and then any external pressures. Real quickly, the pilot. Those are the people who are going to be flying the aircraft, and that means since it's a rocket launch and we're all involved, we're not going to fly rockets unless everybody agrees that it's a good day to fly and everybody is feeling well enough and is excited about and going out and doing the task. Because if someone doesn't agree or is not feeling well, we're just not going to do it, because that's when bad things happen. We're not going to have the rocket launch unless the aircraft, that is the rocket, is ready. Have we done that stability check? Has the parachute been packed properly? Do we have all the equipment that we need, like the blast screen and all that kind of stuff? So we won't fly unless we know that the aircraft is ready. So that's the pilot and the aircraft. Now the environment, that comes down to the weather conditions. And so I have a specific set of weather conditions that we have to have in order to fly. The clouds can't be any lower than 700 feet. We have to be able to have a 3-mile visibility, and the winds have to be less than 10 miles per hour. So we have weather factors to contend with. And then finally, E is for external factors, things that would cause us to do something impulsively, like, oh, we got to get this done because the end of the quarter is getting here and we need to get the data for our experiment so that we can turn in our project. You know what? If it means that I have to turn in grades late, that so be it. I'm not going to do anything unsafe. So make sure that you have everything filled in on your paper as I have written here, and turn that into me to show that you have watched this. I think that you'll agree that the safety management system just makes sure that you're covering all the bases in terms of doing a safe activity. So thank you for watching this all the way to the end, and hopefully in the middle too.